is how we use what's called a congruency statement, how you can set diagrams congruent to one another, how do you put together the correspondence between parts, what is all of this going to mean as we start to get in towards actually writing proofs about congruent triangles. But we need to understand what that actually means about regular things first. So normally what books do, and I think it's about every single textbook I've ever seen, they mix up, when we start talking about congruency statements, they mix it with all sorts of shapes, polygons, regular polygons, irregular polygons, concave, convex. They do all this weird stuff with things. But they do that because they're trying to get you to understand what does it mean when things are congruent. When we talked about congruency stuff before, we said that things were congruent, objects were congruent if they had, what, same measure I think we said before? Same measurements, things like that. If they were equal value, we said that they were congruent. Well, when we get into shapes and figures, what they're going to wind up being, they have to be the same shape, and they're going to have, when we talk about what are called congruent figures, thanks. They're basically going to be, all of the corresponding parts are going to be congruent to each other. Congruent figures have all corresponding parts congruent. Now, if you think about it, if you have a triangle, how many angles are there? 3. How many sides are there?
3.
So if two triangles were congruent to each other, 3 different angles would be congruent to each other, and 3 different side lengths would be congruent to each other. So you wind up with what are going to be called congruency statements. And what I'm going to do first is use one that's not a triangle, because I think it's easier to see what's going on with it. When you label objects, usually, if you guys have noticed, they label things with the vertices, points A, B, C, D, and then makes like a rectangle or whatever. So what I'm going to do is this. Can I go to a clean room real quick to draw some out? Some of you guys are still right now. I'll give you a second here. I'll just have a coffee. It's delicious. People keep telling me I should stop drinking coffee because I don't really need it. You're gross.
I know.
Screw the haters.
Mr. Murphy, I was watching your videos last night. They were cool.
Thank you.
So I didn't know we could hear your voice, and then I heard the classroom, I heard you yelling at people.
You hear these people talking all the time?
Yeah.
Yes.
So funny. Was this going in the video?
Yes.
He's recording it right now. Being recorded right now. Yes.
That's how stuff works.
Just so she.
There's a,
Especially when you're yelling at us,
Yes.
and other people can hear.
yes.
Why do you record this class?
Do everything.
Do you record every class?
Yes.
And then you pick the best one.
No.
Oh, so like it's a different one for each class.
Right.
Yes!
I thought you meant like you record just this class and like all the other classes here.
Oh, I wouldn't choose you guys.
Wait,
We have that down.
so you record
I know.
Thank you.
So let's look at this. Let's say I have a pentagon. Let's say I have a pentagon. Pentagon has how many sides? How many angles?
5.
5.
So let's say we have pentagon A, B, C, D, E.
Should we write this down?
Yes.
It's like a baby.
It's a pentagon, Bella.
Just draw 5 sides. No one's grading your artistic skills. And let's say that this pentagon is congruent to another pentagon.
How do you draw a pentagon?
Let's draw a house.
The other pentagon has to have 5 sides because it's a pentagon. We'll call it F, G, H, I, J. Hey, remind me when we get to polygons, we will do a inscribed pentagon. It is one of the most complex constructions that we do, but if you do it right and you change colors as you're making all your different arc marks, it looks really, really cool. You ever see like the inside of a watch, all the different sprockets and pieces in there? It looks kind of like that. It looks really cool. So what we're saying here is that with just this statement, it tells you everything you need to know about the correspondence between two objects. It tells you you've got two pentagons, because they're 5-sided figures. We don't know what their measurements or anything are or anything, but I do know the following. The order in which they are written tells you the corresponding letters that are congruent to each other. For example, I know that angle A matches up with angle, and the reason that it does that is because they're the first letters. I know that angle D is the fourth letter. It has to match up with angle. That's all this is. It's direct correspondence between the lettering. So what you can come up with here is what's called a congruency statement. A congruency statement is when you list out all the angles that are congruent and then the sides that are congruent. So I can say that angle A is congruent to which angle? F. For argument's sake right now, guys, since I know a lot of this gets pretty messy with all the angle symbols and stuff, is it okay if I just say B is congruent to G? Are we okay for today just to do that? I still want you guys, if it asks you to write out a statement, put the angle symbols in, but I figure for just helping you guys visualize what's going on, if I just do this, it's okay?
Yeah.
Now, all it is just matching up which letter it is within the sequence. It tells you those angles that way. Now, what's the other way you can label angles besides with one letter? 3 letters, very good. Because 2 letters are always correct. Segments or lines, right. So I could have also said angle, if I said angle ABC, what letters would match up the other way? What if I said angle DCB?
IHG.
And that's the idea. The difference with the lettering tells you the direction that you're moving, whether it's with an angle with 3 letters or 2 letters with segments, okay? It just tells you which way you're moving on the object. So B and G match up, C, H, D, I, and E. Does that make sense? It's extremely straightforward. Congruency statements are key. What's important about them as we get on further, when we start proving triangles, is that how we match up our letters is how things will work, okay? So it's important that you keep your letters in some semblance of an order and how you write things out, okay? Same deal with sides. Notice I haven't drawn anything, but if you think about what a pentagon would be, if I just said this was A, B, C, D, E, don't the 2 angle letters make endpoints for segments? Yeah. Consecutive letters create segments in all of these. It does the same thing with triangles. You have triangle ABC, that means you have side lengths AB, BC, and AC. Same thing, or CA, that's how you write it out. So if I go side lengths, AB matches up to what? And so on. This is how this works. BC. Bless you. If I say AE, what would the other one have to be? AE, have to be FJ. But if I say EA, it would be, and that's where you gotta be careful. Okay, that's where you gotta be careful. So, and then A. Okay. What's that? If I said EA, you can do that too.
Okay.
EA would have to match up with JF, very good. Yeah, that's all it is. You just have to make sure you put your letters in the right order.
Okay.
It's customary for me whenever I wrote triangles, because to be honest with you, we'll spend more time with triangles than anything. If I do A, B, C, in my head, I'm thinking it's A, B, BC, and then AC. I don't know why, I just think these two go this way and then there's that side. That's just how I think. But is this wrong to say that you're going around? No, it's not wrong at all. Yes, ma'am?
It's kind of confusing because the C's are like under each other and then now they're across from each other.
When you're listing parts out, you'd be surprised that you're worried about transitives and stuff like that. You're not going to be really so much substituting parts in like that later on when we start talking about actual triangle-proof things, because you're just going to be talking about the segment. You're not going to be switching letters on it. It's a lot less cumbersome. Cumbersome? Cumbersome. I don't know.
Cucumbers.
Potato. All of you, Jedi,
Thank you, I was waiting for that.
I'm not a broad man, but I do know what love is. So, like I said, I know now. Like I said, what we're going to be able to do is stuff like this. We're going to look at two objects. We'll look at two objects. It'll give us a congruency statement, and we'll have to use the congruency statement to figure out what parts equal what parts and solve for x. It is very, very easy. Okay. Baño aquí, por favor. So, it says, whatever this is, some polygon DEFG is congruent to polygon SPQR. Spork.
That's just ridiculous.
You're ridiculous.
Yeah.
The whole system is ridiculous.
It's
I got nothing.
Let's quit.
So, what you're doing here is you're just looking for what parts match up where. How do you figure that out? Well, if I'm trying to solve for x, x in this diagram is brought up in two places. It's brought up at q, because there's 6y plus x, and it's brought up at segment qr, which is 2x minus 4. Now, wise man once said, work smarter, not harder. I know that QR is 2x minus 4. QR is the last two letters. What are the last two letters that correspond to the other object?
G.
G. FG. What is FG equal to? So what do? That's it. You're figuring out what parts correspond to solve it. Because what they're going to do a lot of times is, you notice how these two images are kind of rotated and reflected upon one another? It's not going to be super easy just to look at the picture, oh, that's got to be this one. You'll have to actually read. I know, it's awful. I'm sorry, but sometimes we do have to require you guys to actually read. I'm a jerk, what can I say? So now add 4, divide by 2, and what do you get?
6. Oh. Yeah.
Okay. You get x is 8. Hey, now x is 8. How did I get that? I'll add 4, divide by 2, and you get 8.
Good job.
Okay? Now, if I go back the other way, now that I know that 8 is x, I can substitute that there. So I know that angle Q is 6y plus 8. What does angle Q match up with? If it's the third letter, it matches up with F. So 6y plus 8 has to equal
68.
Should do that in your head. 6 times what plus 8 is 68? 8? Why is 10? There you go. Okay, why is 10? What you're doing here, guys, is we're using these, what are called congruency statements, to figure out what parts equal each other. Basically set them equal to each other and solve. Okay? That's how this stuff works. Terrible? I don't think it's terrible. last one's too easy. These are all actually pretty simple. So. All right, take a minute, figure out. I think it's asking you to solve for x and y. It's nice when they only have one angle to work with and one side length to work with, because that's pretty hard pressed to screw up. I wouldn't put it past you, but it's harder to.
Wow.
Oh,
What do the dots mean? What dots?
Dots.
Is your kid better now?
Like this, it is quite literally that simple, because you only have one angle. You've got D has to match up with A,
No, because there
so you know right away. You have 5.
these are boots. These are.
Okay. And the same deal, you only had one side length, but if you look at it, if you have side length DF, first and last, it has to match up with AC, first and last.
Of course. I plan to forget.
Okay. It's a matter of, yeah, the first couple, because they don't have all those extra parts to them, it really is that easy, because you're just matching over that. Okay. Questions? All right, let me give some props.
I said we just started with
Yeah, I got like 6 of them or so. They're really easy.
I still have like a bunch of energy.
I don't know. Depends on how much you guys annoy me.
I am.
Actually, tomorrow, what I'm thinking about doing is I have all those tests. I'm gonna give back to you guys tomorrow, so you have the shorter period. I'll probably give back tests, go over them, and then just cut and go.
So there's not gonna be
I highly doubt it, because the next step is congruent triangles. I can't do that in 20 minutes. So what I want you guys to do is in the book. It's section 4.2, page 228, 5 through 10, and I'll put these up here in a second.
Wait, are we working on homework already?
Yeah.
Wow.
Heyo. Which means I expect you to be working on the homework.
No problem.
If I don't show work, is this 4.2
4.2.
or 4.3?
4.3 gets real nutty. So what I want you guys to do is this 228, 5 through 10, 19 through 21.
Evens.
5 through 10.
19 through 21.
Now, I will say this right off the bat. I want you to look at number 19. Number 19, you have both variables, x's and y's. So you have to be able to solve what's called a system of equations. Now, when you have that, can I have all the markers? Can I have that purple one because it's darker?
Yeah.
Thank you. When you have systems of equations, what you're looking at here is, if I'm not mistaken, the one with the tick mark is what, 12x plus 4y?
Yeah.
That one matches up to what angle on the other side? 40. So I know this, 12x plus 4y is 40. And then I know that the other angle, 17x minus y, corresponds to the angle that does not have a tick mark on the right. So the one on the triangle on the right, we've got a 40-degree angle, a 90-degree angle, and what's left? 50. So this one has to equal 50. So this is what you call a system of equations. Systems of equations you have to solve, you're solving for both variables. You guys did all of this last year. This was the linear combinations, substitutions, things like that. Whenever you have a system of equations, what you always want to do is try to figure out the easiest way to get it to solve it. Now, that first equation, 12, 4, and 40, what are all three of those divisible by? 4. So if I take out the GCF here, if I divide all those by 4, I get 3x plus y equals 10. Notice now, the y's have opposite signs, and they have the same coefficient of 1. Remember how you would add equations together then? You create 3 addition problems.
Oh, yeah.
What's 17 plus 3?
20.
So you have 20x. Negative 1 plus 1 is 0. So this has to equal, 20x has to equal, what's x? 3. And go on from there. That's how those things work. You're going to use different things of linear combinations and substitutions. It's one of those algebra style problems that does not go away. You will see systems of equations in just about every single math class that you guys can take. At some point in time, I think we still will have time in our Algebra 2 classes to actually work with what are called matrices that solve systems of equations on larger scales. Okay? So that's one of the methods. I'll leave this one up there for you, but I will expect that you guys remember how to solve systems of equations. Okily dokily.
Artichokely.
That one happens.
Thank you.
You got problems.
That's what I want.
That's what's going on. The triangles equal 180, right?
Yeah. Oh, wait. When you're reading that one, though, it's not saying that the triangle is congruent to 180 degrees. Look at the lettering. The triangle LNM has to match up with what other letters? Very good. See how it's talking about the lettering? So what are the letters that it matches up with?
L, N,
Matches up with,
X, Y, Z. So wouldn't they both be 124?
well, careful. You're looking at triangle LNM. What three letters make triangle LNM matches up with the lettering for X and the other one as ZYX? It's just rewriting the statement. It's not talking about an angle. So it's labeling the triangle. Oh, you said X, Y, Z. That's all we're Follow the letters. Follow the letters.